Now tensile stress. I want to discuss tensile stress. Suppose tensile means, suppose this is the body. Here apply the force here P. Suppose F1, and next force is the, suppose F2. So two forces acting on the body is stressed out. Both the forces are acting outside. Means they component, both component is stressed out. So tensile stress sigma T. Okay. Okay. So now tensile stress here, if sigma is positive. First condition is sigma means this sigma. This sigma means engineering stress. Suppose if sigma is positive, means P upon a original cross sectional area is positive. Means P is positive. So getting my points. So see, just 1 minute. Uh, Okay. So now once again I'm repeating. Sigma is positive. Means P upon A naught is positive. Means P is positive. In that case, P is positive load. Okay, no? So tensile stress basically, if sigma is positive, then stress is tensile. Simple meaning, if sigma is positive, means sigma positive, load positive, means stress is tensile. So this is called tensile stress. Okay, tensile stress. Okay, simple meaning, this is the tensile stress. Now we define here. The fibers of component tend to elongate due to the external force. Fiber of the component. Okay, this is the component. Fibers of the component made of unlimited number of fibers here. Okay, now fibers. So fibers of the components or elements or the body or the bar or the component are tends to elongate due to external force. Due to external force, a member subjected to external tensile force P and tensile stress distribution due to the force is shown here. See, just 1 minute. This is the suppose component. Okay, this is the here component. Just 1 minute. I will explain everything. Don't worry. So suppose this is the here component here. Okay. Okay. So suppose this is the component here. Just 1 minute. Okay. So this is the component. So we want to suppose here taken in this manner. This is the component. Okay. Now we elongate here in this manner. Suppose this is the, choose another color. Suppose we want to choose the red color. So here now this is the component here. Okay. So we make the hair. So this point here. Okay. So we make the, okay. So this is the cross section area, and we make here the, this is the shear stress distribution. Sorry, this is the stress distribution in this manner. Okay. So here load of P is applied. Tensile force, external force applied. Okay. So here load is applied as a tensile force. Just see the diagram. Okay. So this is the diagram basically. I have already explained. And here sigma tensile force means here sigma T acting outward direction. Okay. Means and into area applied. then this is called force. Means sigma T in outward direction into area of this component. This is the area. Okay. So area into sigma T, this is called the force applied on the component. Okay. So now if we want to discuss compressive stress, suppose compressive stress, in that case, sigma C, sigma is negative. That is called compressive stress. Means P upon original cross-sectional area is negative. Means P is negative here. P is negative means sigma negative means this is called compressive stress. This is called compressive stress. Okay. Now in that case, suppose I want to discuss in similar manner. See if sigma is negative less than 0, then stress is compressive. That is called stress is compressive stress. Now the fibers of the component tends to shorten. Fiber of the component tends to shorten due to the external force. A member subjected to an external compressive force P and compressive stress distribution due to the force as shown in the figure here. Suppose this is the figure. Just one minute. This is the diagram here. This is the diagram. Okay. Bar, suppose. Here applied compressive force. This is the compressive force. Suppose PC. And here fibers. So this is the fiber compress. So these are the stress distribution in this manner. Okay. This is the stress distribution in this manner. So here compressive force applied. Suppose this force compressive force applied. So means here sigma C into area. Sigma C into area. This is a compressive force. Okay. This is a compressive force. Okay. This is the compressive force. Okay. Okay. So now I have already explained regarding sigma T and sigma C. Sigma T means tensile force, sigma is positive, then we obtain tensile force. Sigma C negative, then we obtain sigma C, means compressive stress.